This presentation is intended to give you information about the tentatively selected plan identified in the Draft Integrated Feasibility Report and Environmental Impact Statement prepared by the U.S. Army Corps of Engineers in collaboration with the Texas General Land Office for the Coastal Texas Protection and Restoration Feasibility Study, also known as the Coastal Texas Study. The plan is only a tentatively selected plan until reviews of the draft report are complete. After the review and public input process, and if it is determined that the plan meets performance goals, is economically justified, and is environmentally acceptable, it will become the recommended plan. For this presentation, when we say the plan, we are talking about the tentatively selected plan. The study area consists of the entire Texas Gulf Coast, from the mouth of the Sabine River to the mouth of the Rio Grande, and includes the Gulf and tidal waters, barrier islands, estuaries, coastal wetlands, rivers and streams, and adjacent areas that make up the interrelated ecosystems along the coast of Texas. The Coastal Texas Study Team, comprised of the U.S. Army Corps of Engineers and the Texas General Land Office, formulated the plan through a detailed analysis and evaluation process to determine the feasibility and impacts of constructing an integrated system of large-scale coastal storm risk management and ecosystem restoration measures that work together to restore and enhance the state's ecologic coastal features and reduce the risk of coastal storm damage and loss of life. Coastal storm risk management measures consist of structural features that include levees, floodwalls, and navigable and environmental flow surge barrier gates. Non-structural measures such as raising houses and buying out flood-prone properties also reduces storm risk damage over time. Ecosystem restoration measures or actions increase or improve habitat and reduce shoreline erosion through marsh, beach and dune, oyster reef, and island restoration. These measures focus on critical geomorphic features and important coastal ecosystems including wetlands, seagrass beds, sea turtle nesting habitat, piping plover critical habitat, bird island rookeries, and federal and state wildlife refuges. These ecosystems have been degraded following years of coastal forces such as wave erosion, storm surge, and relative sea level rise, which remove sediment from beaches and marsh. Coastal storm risk management and ecosystem restoration measures were developed and evaluated through several iterations of screening and then assembled into alternatives to address the specific needs of the Texas coast. The plan includes three main components. 1. Ecosystem restoration throughout the coast. 2. A coastal storm risk management system to address storm surge in the upper Texas coast, known as the coastal barrier. And 3. A coastal storm risk management measure to address erosion in the lower Texas coast. Let's investigate the three components of the plan, starting with ecosystem restoration. Restoration actions address habitat loss and degradation from coastal processes and also support the coastal storm risk management components of the plan by providing a natural buffer from coastal storms. There are 9 ecosystem restoration measures, several of which include a combination of efforts to restore diverse habitats. The combinations of measures provide habitat and work together, forming multiple lines of defense. Let's explore some of the details of each type of ecosystem restoration action proposed in the plan. Marsh restoration improves degraded marsh habitat or restores habitat that has become open water due to erosion, relative sea level rise, or other coastal forces. Breakwaters will be placed to reduce erosion, and sediment placed behind the breakwaters increases the elevation of the land to restore or maintain fluctuating water levels as tides vary. Restoration also includes planting of native marsh vegetation to provide habitat and trap sediment, thus reducing erosion. Beach restoration places sand dredged from offshore sources or from nearby navigation channels on degraded Gulf shorelines to restore dune and beach habitat. To maintain the habitat over time, sand is replaced at regular intervals. Island restoration includes placement of sediment to increase the elevation of degraded islands. These restored islands include shoreline stabilization along the Gulf Intercoastal Waterway to withstand erosion and will provide bird nesting habitat. To increase the diversity of habitat and provide natural erosion control, the bay side of the island will slope to a created marsh and oyster reef. Hydrologic restoration is the re-establishment of a connection between water bodies to maintain salinity balances that sustain habitats. Each ecosystem restoration measure name has a unique identifier with a number and letter corresponding to the county where it is proposed. This measure would restore approximately 26 miles of Gulf shoreline from High Island on Bolivar Peninsula to the Galveston East Jetty and 18 miles of Galveston Island shoreline west of the Galveston seawall. This will result in approximately 5,050 acres of enhanced shoreline. This measure includes restoration of approximately 36 miles, resulting in 664 acres of marsh habitat, along with the Gulf Intercoastal Waterway on Bolivar Peninsula and along the north shore of West Bay. It would also restore approximately 326 acres of islands adjacent to the Gulf Intercoastal Waterway along a 5-mile stretch on the north side of West Bay. 18 acres of oyster reef would be created on the bay side of the restored islands. Future adaptive actions may nourish an additional 7,000 acres of marsh that are expected to be lost based on impacts caused by relative sea level rise. This measure would restore beach and dune complexes on approximately 10 miles of Gulf shoreline on Follett's Island in Brazoria County, enhancing approximately 1,100 acres. This measure would restore approximately 550 acres of estuarine marsh shoreline in Bastrop Bay, Oyster Lake, Cowtrap Lake, and the western side of West Bay. In the area of Oyster Lake, oyster reef would be created to prevent the lake from joining with West Bay. Future adaptive actions may nourish an additional 20,000 acres of marsh along the Gulf Intercoastal Waterway that are expected to be lost due to relative sea level rise. This measure would restore approximately 240 acres of estuarine marsh along 12.5 miles of the Big Boggy National Wildlife Refuge shoreline and eastward to the end of East Matagorda Bay. In addition, approximately 93 acres, or 3.5 miles of islands adjacent to the Big Boggy National Wildlife Refuge along the Gulf Intercoastal Waterway would be restored, including additional oyster reef creation. Future adaptive actions may nourish an additional 6,000 acres of marsh along the Gulf Intercoastal Waterway that are expected to be lost due to relative sea level rise. This measure would place breakwaters to reduce erosion along approximately 4 miles of shoreline between Matagorda Bay and Keller Bay, and approximately 2 miles of oyster reef would be created on the western reaches of Keller Bay. Future adaptive actions may nourish an additional 620 acres of marsh. This measure would restore 5 miles of estuarine marsh along the Matagorda Bay shoreline of the Powderhorn Lake area. This measure would restore the island complex of Dagger, Ransom, and Stedman Islands in Redfish Bay. An approximate total of 390 acres of habitat across 6 islands would be created in the complex. Oyster reef would be created in the interior of the island complex to provide additional habitat diversity and enhance submerged aquatic vegetation growth. This measure would dredge about 7 miles of the Port Mansfield Channel from the Gulf of Mexico westward towards Port Mansfield to restore and maintain the hydrologic connection between the Laguna Madre and the Gulf. Beach quality dredge material would be used to nourish 9.5 miles of beach north of the channel, and the rest will be used to restore 28 acres of an existing bird rookery island. A breakwater would be placed around the island to reduce erosion. Now let's take a closer look at the second component of the plan, the Upper Coast Coastal Storm Risk Management System, known as the Coastal Barrier. This coastal storm risk management system is designed to address storm surge through the construction of structural features including flood walls, floodgates at highways and railroads, seawall improvements, and surge barrier gates. Non-structural features such as raising homes and buyouts in the Galveston Bay area are also investigated. A unique feature of the coastal barrier is the pass to Galveston Bay between Bolivar Peninsula and Galveston Island. This feature includes surge barrier gates that are made up of a 1,200-foot navigable floating sector gate and environmental lift gates. The alignment of the coastal barrier is divided into 4 sections surrounding the surge barriers, based on construction sequencing and similarity in features. The 4 sections are the Eastern Tie-In section, the Bolivar Peninsula section, the Galveston Ring Levee, and the West Galveston Island section. The coastal barrier also includes surge gates with associated pump stations at the Clear Creek Channel and Dickinson Bayou. The Eastern Tie-In section would include a raised roadway that would serve as a levee starting near Mud Bayou south of Stowell and would follow the existing State Highway 124 until reaching the Gulf Intercoastal Waterway just north of High Island. Impacts to the Anahuac National Wildlife Refuge would be avoided as much as possible. The system would then cross the Gulf Intercoastal Waterway on the west side of State Highway 124 with a sector gate that would accommodate vessel traffic. The sector gate would tie into the south side of the Gulf Intercoastal Waterway and then transition to a levee that would continue southward on the west side of State Highway 124 until tying into natural high ground in High Island. The next section, the Bolivar Peninsula section, would consist of 27 miles of levees and flood walls as well as highway gates. The section starts at High Island with a levee on the east side of State Highway 124. The levee would run south to the vicinity of Port Bolivar and the State Highway 87 ferry landing. The Bolivar Peninsula section would then transition into the next section, the Bolivar Roads Crossing. The Bolivar Roads Crossing would consist of a 1,200-foot floating sector gate, 38 100-foot vertical lift gates for tidal exchange, and a 100-foot recreational gate. The design would allow for future deepening and widening of the channel. The sector gate would be housed in man-made islands on either side of the entrance to the Houston Ship Channel. Construction of the sector gate across the Galveston Harbor entrance channel would require a temporary bypass for navigation located north of the existing channel. The channel crossing would continue south of the sector gate and would tie into high ground near the end of the existing seawall on Galveston Island. To address storm surge flooding from the bayside, the Galveston Ring Levee would be constructed around the highly developed and low-lying portions of the city of Galveston. This feature consists of 18 miles of levees and floodwalls, highway gates, railroad gates, a 2,400-foot crossing of Offutt's Bayou with surge gates for navigation and environmental flow, pump stations, and 8 miles of existing seawall raising. Because Galveston Island currently operates on a gravity drainage system, the plan would include a forced drainage system consisting of several pump stations to move water off the island. The Galveston Ring Levee would tie into a 15-mile levee and floodwall system that follows the west end of Galveston Island to a tie-in point at the San Luis Pass Bridge. San Luis Pass will not have a closure structure. When facilities are in direct alignment of the system, levees would transition to floodwalls to minimize impacts. The coastal barrier system would also include closures at Clear Creek Channel and Dickinson Bayou to address wind-driven surges in the bay. Both areas include surge gates across the channel and associated pump stations. Non-structural measures, such as raising houses, would be implemented along the west side of Galveston Bay to reduce damages from wind-driven bay surges. Elevating structures is a common approach already being undertaken by residents and businesses in the area. Maintaining tidal exchange between the Gulf and the Bay is a priority. The barriers would be closed only for storms and maintenance. Other large surge barriers worldwide are closed an average of 1 to 3 days per year for storms and operation and maintenance activities. There are opportunities to optimize the design and alignment of the coastal barrier to minimize impacts to existing structures and the environment on Bolivar Peninsula and Galveston Island. In future planning and design phases, the study team will refine specific details of the coastal barrier, such as levee heights, pump station sizes, use of non-structural features, and precise project alignments. Future design efforts may identify sites where engineered dune systems could be built along the beaches rather than levees and floodwalls. Now let's take a closer look at the third and final component of the plan, The Lower Coast Coastal Storm Risk Management Measure. The Coastal Storm Risk Management Measure to address erosion and storm surge in the lower Texas coast consists of a little over 2 miles of dune and beach nourishment along South Padre Island. The nourishment would be aligned parallel to the existing beach and dune system and would begin 2 miles from the Brazos-Santiago Pass North Jetty system and end approximately 4 miles from that same system. Currently, the measure consists of a 12.5-foot dune and a 100-foot wide beach berm, with additional sand to be added every 10 years. The Texas General Land Office, as the local sponsor of the study, is interested in exploring a larger extent of beach and dune restoration along the entire South Padre Island from the Brazos-Santiago Pass North Jetty system to almost 6 miles north of the jetty. The study team has calculated the total cost to implement the plan to a range between $23 billion and $32 billion. This range is based on the best information available during the development of the draft report and reflects potential changes in material costs, schedule, and unforeseen issues. The study team will continue to develop and refine project costs in the future planning and design phases of the study. We are currently in the public comment period for the draft integrated feasibility report and environmental impact statement. Following this period, the study team will review and address the input received from the public, resource agencies, and Corps and GLO leadership to produce the final report. It is anticipated that the final integrated feasibility report and environmental impact statement will be published for public, state, and agency review in 2021. Once the final report is approved and the project receives congressional authorization and funding, the study will then enter the design phase for further refinement. Construction of the recommended plan is dependent upon congressional approval. The recommended plan identified in the final report would be built over a period of 10 to 15 years, depending on congressional authorization and partnerships. The project would be maintained after construction by local sponsors. The Corps encourages full public participation throughout the study process to promote open communication on the issues surrounding the study. In addition, participation by federal, state, local agencies, and other interested organizations is encouraged. As part of the National Environmental Policy Act, or NEPA, process written comments may be mailed to U.S. Army Corps of Engineers, Galveston District, attention Ms. Jennifer Morgan, Environmental Compliance Branch, Regional Planning and Environmental Center, P.O. Box 1229, Galveston, Texas 77553-1229. Comments may also be submitted electronically to coastaltexas@usace.army.mil. All comments must be received or postmarked by January 9, 2019. Additional questions or comments that are not part of the NEPA process can be sent to coastaltexas@usace.army.mil at any time. More information about the project can be found online at coastalstudy.texas.gov. We thank you for your interest and look forward to hearing your feedback.